Okay, today we're going to talk about inverses. But we need to talk about a big problem with inverses and how they work with sine, cosine, tangent, cosecant, secant, and cotangent, because there is a problem that occurs. Now, all of us should remember, or hopefully this is a refresher for you, from Algebra 1, we talked about in order for something to be a function, it must pass the vertical line test. So a graph must pass the vertical line test in order to be even a function. That is, for every input, there's exactly one unique output. That is the vertical line test. That's where you took a vertical line and you scanned it. As long as it hit one place, then it was a function. Well, in order for an inverse, in order for there to be an inverse, it has to pass what's called the horizontal line test. That's what it says here. A graph of a function must pass the horizontal line test in order to have an inverse. That is also a function, also known as being invertible. So, to check if something is a function, you do a vertical line test. To check to see if its inverse is also a function, you do something called the horizontal line test. So, for example, this graph right here, it's a function because it passes the vertical line test. Every vertical line I put through there will only hit once. It also passes the horizontal line test. So it is invertible and it is a function. And how you might want to show that is I do something like this, where we just go, okay, it hits once, and that's it. So this is a function, and it's invertible. Our next one is also a function. It passes the vertical line test. No matter where I put a vertical line, it will only hit once. There's just one output for every input. However, if I turn it horizontal, it no longer passes that test. So if I'm doing a horizontal line test, it's going to hit once, twice, 3 times, at least 4 times. It can only hit once. So this is a function, but it is not invertible. Yeah.
Is it supposed to say following?
No, it shouldn't say following.
Okay.
It should probably say following, right? Probably. Context clues. It should be. I don't think we're following anything. Follow sounds cool though. All right, our last one. Vertical line test. It is a function.
But there's lines that it doesn't touch, right?
That's okay. As long as every vertical line you put on there hits at most one place. If I put a line here, it hits 0, but it's still okay. That is still less than 2, right? As long as it's 1 or less. So even though it's not going to hit here, it's still a function. However, if I put a horizontal line in there, that does not pass. So at most, I should say at most, it can hit 1 point. So it is not invertible. So that was kind of a review for one really big aspect. Picture any trig function. Sine, cosine, cosecant, secant, tangent, or cotangent. None of them pass the horizontal line test, which means they're not invertible. So as they stand, you can't take the inverse of it. But if we didn't find a way to fix that, we would be done with this chapter right now. There is a way to remedy that solution. And in fact, if you look down a little further, you can see you're finding the sign inverse of something. So it means that we figured out a way to adopt the fact that, hey, it's not quite invertible, but we're going to make it invertible. And it's going to work this way. What we're going to do right here in the middle is we're just going to do a sine graph. We're going to do a normal sine graph. So that means it goes up to 1, down to -1. Well, sine starts at 0, 0. It goes up to 1. At pi, it comes back down to 0. goes down to -1, and goes back to 2 pi. I'm also going to go one step further. I'm going to graph backwards a little bit. So at -pi/2, I'm going to go down to -1. So this is our normal sine graph. That right there is just sine of x. Just graphing one cycle of it, we can see that it doesn't pass the horizontal line test. It would hit twice. In fact, it would hit an infinite number of times because this just keeps going up and down. So what we did as mathematicians is we said, okay, if it doesn't pass, we'll just chop it off. We'll just chop off a section of it and say, well, that little section right there is invertible. That is invertible. It passes the vertical and the horizontal line test. However, that means for this inverse to work, the inverse only exists between -pi/2 and pi/2. So if you look at that unit circle on the left, we actually cross out all of this. And sine inverse only lives in quadrant 1 and 2. So it lives between pi/2 and -pi/2. Russ?
So we only have to know that part when we use it.
For sine inverse, yeah. And in fact, I'm going to point out why you can only focus on that in just a second. Why did we do this? It'll make more sense when we're actually solving these problems, why we have to go down to these two quadrants. Yeah, Safa.
Why is it that side quadrant? You just asked that.
So are you saying why didn't we chop it off here?
No, I meant like why can you cross off that particular half? Why don't you do quadrant 1 and quadrant 2?
Because if we do quadrant 1 and quadrant 2, I'd make my box here, which is no longer invertible because it doesn't pass the horizontal line test.
Okay.
I'm saying if I restrict this graph to -pi/2 and pi/2, it is now invertible.
Okay.
All right. You could have restricted it over here, but we didn't. It is always here. This is in every single math book. This is fully understood. Your calculator uses the same thing. It cuts off sine from -pi to positive pi/2 so that you can find the inverse. All right, it's a little arbitrary why you picked right there, but we did, and it's permanent. Okay? So that means we are restricted to quadrants 1 and 4. All right, then we're going to do the graph of sine inverse. To graph an inverse, you just need to find key points and flip your x and y values. That is how you graph an inverse. So you find your x and y values, you flip them, and plot them over here. So for example, this point right here is -pi/2, -1, in that order. Your x value is -pi/2, and your y value is -1. Flip it. Your x becomes -1, and your y becomes the -pi/2. So we're going to go -1, -pi/2. That'll be my first point. 0, 0, you flip it, it is still 0, 0. Finally, my x and y value here, my x value is pi/2, my y value is 1. So this is the point pi/2, 1. Flip it, it becomes 1 pi/2, so we go 1 pi/2. Yes?
I'm confused because that looks like the same graph.
It looks similar to the same graph. Look at the x and y values.
Well, no. Yeah, but...
And it's going to look a lot alike because if you remember from inverses, all an inverse does is it flips across y equals x. So it's going to look the same, but this is now going to be flipped down. So this graph will actually look like that. It is just inverses, guys.
What are you flipping?
To find the inverse of a graph, you flip it across y/x. So if you flip this over your y/x, you have your inverse.
Oh, okay.
I don't have time to teach inverses right now. Yeah.
No,
Yeah.
Something in the red box? Or
Yeah,
just
just what's in the red box. Yep, just what's in the red box. Because that graph right there is the graph of sine inverse x. And if you don't get how that happened, just know what the graph is. All right, just know the graph. Just study the graph and be able to reproduce it. I'm not asking you to do any shifts on it. You're not going to shift it left, right, up, down. We're not going to stretch it. If I ask anything about the graph of sine inverse, that's all I want to see out of you. All right, we're not going to shift or anything. That's all I want you to do. All right, so that's how we get that inverse graph. It's just a chunk of our sine where we take the inverse of it. Now, why is this important? Every function has its inverse. If I go x squared and I want to undo x squared, I just take the square root of it. Square root of x squared is just x. And when you take the square root, you're actually doing the inverse of x squared. That is what sine inverse is. It undoes what our trig functions do. So for example, if you look at your unit circle, in fact, you might as well just take out your unit circles now, because we're going to need them. If I ask you to find the sine of pi over 4, you're going to look at your unit circle. You're going to find pi over 4 in your unit circle, which is like halfway in your quadrant 1. Then you're going to look for your y value, which is square root of 2 over 2, and you'll be done. The inverse goes in the completely opposite direction. The inverse says, well, I'm going to give you square root of 2 over 2. And the inverse is going to give you back out that angle. So sine gives you a number. Sine inverse will always give you the angle where that number occurs at. So sine inverse gives you an angle. Sine gives you a value. That's important to know. Sine inverse gives you back out an angle every single time. So let's go ahead and try this. So we're going to do sine inverse of 1/2. Can I take a picture of someone's unit circle real quick?
You can take a picture of mine.
Oh, thank you.
You're limping a lot lately. I noticed that.
What was that?
You're limping.
No, I'm not. I just ran 6 miles yesterday. I can't be limping.
Well, you got me napping while you're running. I'm in the corner.
All right. I'm glad we don't have all the values. That would be nice.
Wait, we don't?
That'll be okay. All right, so I'm looking for the sine inverse of 1/2.
Can't you get 2?
What was that?
Oh, we don't look at the quadrant 2 and 3, right?
Well, let's just hold off on that for just a second.
Okay.
Because it's exactly what you just said. Oh, man. The picture disappeared. Aw.
Where's your big one?
It's stuck behind there.
Whoa, wow.
I don't know. My thing just disappeared. Can I take a picture of yours real quick? Yours right here.
What?
Hers is right here. And it's got tangent values on it and everything.
Well, I didn't get that far.
I'm just kidding. I'm just kidding. All right. All right, so we are looking for where sine equals 1/2. Here's the problem. Sine equals 1/2 right here. And sine also equals 1/2 right here. If I ask a question, I want one output only. Yeah, Safa.
Isn't it going to be quadrant 1?
Yes. That is why we need to constrict it to just 2 quadrants. Because right now, sine has 2 possible places where it's 1/2. So when we came up with our inverse, we said, forget about this side. We have to constrict it to quadrant 1 and 4. So now we're just going to look for where sine equals 1/2. And the sine inverse of 1/2 is going to be pi over 6. So that's going to be pi over 6. Or 30 degrees. I didn't ask for degrees or radians, so you could give them the answer in anything they wanted. All right, the next question is, where is sine negative square root of 2 over 2? Here's where it gets a little tricky. Nora.
Isn't it just 7 pi over 4?
You would think so, right? You would think so, but it's not quite. I am going to circle it. You are looking in the exact right place. You're looking at the right place. But let me bring up the graph one more time.
Wait, isn't it because it's inverse, so it's going to be pi over 4?
Almost. You're really close. I want to bring up the graph really quick. 7 pi over 4 is right here. Is that part of my graph? No. We are only between negative pi over 2 and pi over 2. So what you need to recognize, Ross, it isn't undefined. Yeah. Not 315 degrees. Once again, 315 degrees is not on that either. Yeah. It's going to be negative pi over 4.
Wait,
This distance here,
which one are we on?
You are on the side.
What was that?
So
I will.
If that's on the top, is that just on the bottom negative? Is
yes.
that where you're telling
Yeah.
us? Okay. Then
It just goes
So we
backwards.
can only choose pi over 3, pi over 4, pi over 6, and then the negatives of those?
Yeah.
Okay. So,
yeah.
Yeah.
Oh yeah.
Yeah.
Yeah. Go ahead.
Whoa! You know what I just realized?
what?
So it's pi over 3, pi over 4, pi over 6, and the bottom one just has numbers.
Well,
Mary.
Sorry, I'm so confused.
Okay, that's okay. Are you okay with this being the angle I'm looking for here?
Yeah, I get that part.
All right. Shh, 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 shh. If this is positive pi over 2, this distance here would be negative pi over 2. I'm going in the negative direction. All right, and we need to go in that negative direction because this goes from negative pi over 2 to pi over 2. You can't name any angles bigger than that. So as sine inverse, you have to either list a pi over 6, pi over 4, pi over 3, or you have to have negative pi over 6, negative pi over 4, negative pi over 3, negative pi over 2. Bree, do you still have a question?
No.
Okay.
Wait,
Nope.
so in the answers there won't be any numbers, like above or pi. Like it'll just be pi or negative pi over.
Yes.
So
Yep.
it would be negative 45 degrees.
It would be negative 45 degrees as well. Yep.
I
What's
actually.
the arc sin mean?
Arc sin,
is it the same?
we'll get to that. It will be the exact same. That's why we're going through this one. So it's negative pi over 4 or negative 45 degrees. Now if we look up here, arc sine is the exact same thing as sine inverse. So my advice to you, because some people get really messed up when I say arc sine, as soon as you see arc sine, just think, well, that's just sine inverse. It means the exact same thing. It's 2 words for the exact same thing. All right, so don't let the arc confuse you. A lot of times we can just rewrite it. Mike, can you pick up your head? Thank you. All right, so that's negative pi over 4 or negative 45 degrees. All right, who can give me the sine inverse of square root of 3 over 2? Bree.
Pi over 3.
Pi over 3. We're all okay with that?
Wait, when? Wait. Why did we give the angle for the last one?
And we give the angle for all of them. Oh, well, we could do the same thing here. Pi over 3 is just 60 degrees.
Oh.
I just said I did not specify what you had to give me.
Okay.
Generally, if I don't ask, I'm usually looking for radians, but if you give me degrees, I can't take any points off, so why not both? It is epic. I don't know if it's really epic, but...
What if you put the right radian number value? What are the quantities? The wrong degree?
I will most likely cross out the... As long as I didn't ask...
So we can just guess the degrees if we forget. Just try to get out which one. Then you just cross out the wrong one?
No. If you're doing that every time where you're just guessing, so you have 2 guesses in one. You're like, I'm not sure if it's pi over 3 or it might be 270 degrees. I don't know. I'll put both of them down. No, don't do that.
Uh-oh.
Not a loophole. All right, let's do cosine. Let's do cosine. Cosine is going to be similar. A regular cosine graph starts at 0, 1, pi over 2, 0, pi negative 1, 3 pi over 2, 0, and 2 pi is at 1, and it looks like that. Once again, it is not invertible. It does not pass our horizontal line test. So once again, some mathematicians came together and said, where are we going to constrict this thing so that it is invertible? And they just picked the easiest possible. They just went from 0 to pi.
So it's different spots.
Different spots.
So is it just quadrant 1 and 2?
It is just quadrant 1 and 2, which is good for you because you don't have to worry about negative angles then.
Wait, 1 and 2, that's the top ones.
It is the top one.
Nice.
Good point.
Well, I thought it would be like the opposite of sign.
It is quadrant 1 and quadrant 2, and we can forget about 3 and 4. So we're just dealing with quadrant 1 and quadrant 2. Once again, if I needed to graph the inverse of this, after we're done graphing this, you can just memorize it, or you can look up how to find inverses of graphs. But in short, it is find the point and flip your x and y values. So this is the point 0, 1. Flip it, you're looking for 1, 0, which is right here. So this is going to be completely different points. Then we'll take that negative pi over 2, 0, flip it, and it's going to be 0 pi over 2. So that's up here. And finally, we had pi, negative 1. We're going to flip it and have negative 1 pi. And when I fill these in, it's going to look like that. Epic?
No.
It's not epic?
I don't understand
For what
the
one?
box.
Inverse.
What values am I flipping? Well, I'm just finding those 3 key points. So I'm finding this point is 0, 1. When I flip those, I'm going to be plotting 1, 0. This center point is pi over 2, pi over 2, 0. If I flip it, it will be 0 pi over 2. And my final point was pi negative 1. Shh, guys. I'm going to flip that, and I'm going to have negative 1 pi. So I just take the x and y values and I flip them. Okay. Like I said, the only thing I care about that graph is just know it. Basically kind of just memorize it if you don't know how to get it. Because all I'm going to ask you to do is graph cosine inverse. That's all I'll do.
Like on the quiz.
Or on the test.
Oh, yeah.
Or on a quiz. I'm just saying I won't ask you to flip it, like put a negative. I'm not going to change the amplitude of it. I'm not going to. This is it.
So that,
If I say anything about graphing cosine inverse, this is all I'm asking for. I don't ask you to shift it up, down, left, right, stretch it, or anything. So if you just memorize that, you'll be okay with that. All right, let's go ahead and do this. So I need to find the cosine inverse of 1/2. Once again, I'm looking for where cosine equals 1/2. But if I look for where it's just 1/2, it's here. And it's also 1/2 right here. But the good news is we said we're only looking in quadrant 1 and 2, so that one just goes bye-bye. And so we only have one possible. That's pi over 3, 60 degrees.
Wait, can you go back to that page?
I sure can. You also have it right in front of you, too.
No.
No?
Wait, no, before that. Yeah, that one.
Oh, okay.
Alright.
I can leave it up there because I have these pi over 3, which is also 60 degrees. Arc cosine. Just think cosine inverse. Don't let the arc throw you off. It doesn't mean anything different. What is the arc cosine of negative square root of 2 over 2? Yeah. Negative pi over 4?
No.
I think we're in the wrong quadrant.
Yeah,
It only can be 1 or 2.
It's not.
Mary? 3 pi over 4.
No, one's for a
No.
sign.
No.
Oh, it's completely different. Yeah,
It is completely different because if I look at the graph, I can do anything between 0 and pi. So I can go boop, 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 anywhere I want.
Well, yeah, I know that, but in the last one, you could do anything between the first quadrant and the fourth quadrant, but you made all those equations in the fourth quadrant the same as the first quadrant. You know what I'm trying to say?
I do know what you're trying to say. Well, so here's the thing. So if I'm doing an angle, I am fine anywhere across here. This is from 0 to pi. Everything is fair game because 3 pi over 4 is somewhere between 0 and pi. In fact, 3 pi over 4 is right here. That is in that section I circled. Let's go back to that sine graph.
Oh, okay.
The sine graph, the first one was 7 pi over 4, which was way out here. It's no longer part of what's in the circle. So that's why I had to use the negative coterminal angle of that. All right, so we have 3 pi over 4 for that one. Who can give me the arc cosine of 1? Arc cosine of 1. Markle.
0.
0. Cool. Which is also 0 degrees. All right, let's review. Or let's get to Nora's question.
Sorry.
No, that's okay.
Also use 2 pi for that one.
You cannot, because look where 2 pi would have to go. I'd have to go all the way across here through no-no land. You can't go through no-no land because 2 pi is actually over here in no-no land. So if you ever have to travel through that no-no land, it's a no-no. It's a no-no. She asked, could you also use 2 pi, and that 2 pi would be wrong.
Oh, okay.
2 pi would be wrong because you have to travel through this no-no land.
Okay. It's actually just
All right,
It's a half circle.
let us review. Quick recap. How is a quick way to remember where inverses live? This is how I remember it. To this day, I write out cosine, and I just put inverses on there. And then I just get rid of that quadrant there. So you just have to remember cosine inverse. Then you know where your inverses live. All right, I'm also going to put a little note in there. Cosine inverse and sine inverse will always result in an angle. So that means you'll always get, if you're in radians, you'll get like pi over something, or in degrees, it'll always be something in degrees. That's important because sometimes I'll say the sine inverse of square root of 2 over 2, and then people will put square root of 2 over 2. You didn't give me the angle, you just gave me what I just asked for. So they actually find square root of 2 over 2 and then just put that down.
That's like 2x.
What was that?
That's like 2x.
That's 2 what? I didn't hear.
IQ.
Oh. Okay, anywho. Can someone give me the cosine of 3 pi over 4? Bree?
Negative square root of 2 over 2.
Yeah. Can someone give me the cosine inverse of negative square root of 2 over 2? It's 3 pi over 4. So there are times where it completely is the opposite. So the cosine of 3 pi over 4 gave me negative square root of 2 over 2. Cosine inverse of negative square root of 2 over 2 undid what just happened and left me with 3 pi over 4. Sometimes it's nice where it does that. Other times it kind of breaks down. And that's my example right here. Can someone give me the sine of 7 pi over 6? Jacob.
Negative 1/2.
Negative 1/2. Can someone give me the arc sine of negative 1/2? Priya? Negative pi over 6. And that is because 7 pi over 6 does not exist in sine land. That's part of the no-no land. So you need to find that coterminal angle, which is negative pi over
Wait, I have a
6.
question.
I don't have an answer for you.
Oh,
Okay, yeah.
I
Okay.
feel like we went over it,
Shoot it.
sort of. But why isn't it 11 pi over 6?
that's in.
It's in no land.
Notice that it's for sine.
Well, first, that's the wrong place. You should have looked for 7 pi over 6.
Yeah.
Yeah,
no,
yeah.
No, for negative 1/2.
Okay?
Okay.
Arc sine of negative 1/2, right?
Like, yeah.
So if I bring all of this back, and I get rid of all of this junk,
It's right here.
It is right there.
It's 11 pi
So
over
we
6.
talked about earlier.
Yeah, but I
For
never
sine, you just
got an
make-
answer.
Oh, okay.
That.
Okay, so remember 11 pi over 6, okay? Remember 11 pi over 6. If you look here on the graph where I condensed the two, 11 pi over 6 is right here.
Oh.
Is that in that area here?
No.
No, you have to actually go
But
negative.
It's in one of the quadrants that we chose.
Cool.
What? I thought that was
But there's lots of coterminal angles there. I could add 2 pi and it's in quadrant 4. I can add 2 pi and it's in quadrant 4.
Okay.
No, Mark, you have to specifically pick angles between negative pi over 2 and pi over 2 to fit in this little box.
Can I explain something?
Sure.
Please.
In the, you see the when you circle the X?
Yes.
So these on the bottom, since like it's going below it, you have to put negative pi over 6, negative pi over 4, negative pi over 3 instead of these.
Because the bottom is not 3 pi over 2 anymore. It's negative.
All right, the last thing we have to cover is just using our calculators. And not just using our calculators. Well, you have your 2 graphs here. All right. All right, we're going to use our calculators, but first we have to understand what we're doing. So this says sine alpha equals 0.88. Sine alpha equals 0.88. I need to have alpha equals. You can't plug sine alpha equals 0.88 into your calculator. You cannot do it. So what you need to do is we need to do a little bit of something on this side. I need to get rid of that sign. That sign can't be there. To get rid of that, we are going to take the sine inverse of that side. And your sine inverse and your sine undo each other. That's what it means to be an inverse. That is the definition of inverse. Just like if I take the square root of x squared, I get rid of the squared. All right, that's the definition of inverse. But what I do to one side, I have to do to the other side, so I'd have to take the sine inverse of the other side. And I'm just left with alpha. That's not an alpha. That's an alpha. Equals sine inverse of 0.88. Now we're going to plug this in our calculator, because obviously I'm not looking for an exact, because 0.88 isn't on my unit circle. So the first thing I'm going to do is I'm going to look at the directions. The directions say it needs to be between negative 90 degrees and 90 degrees. So that means I need my calculator in degree mode. So we're going to get our calculator out, my little wabbit. I'm going to clear that because those are our answers. I'm going to go to my mode. I'll make sure it's in degrees. It is in degrees. Get out of there. And then if you look right above sine, there's a sine inverse button. So you're just going to hit second sine, and it should come up with sine inverse. And then you're just going to put 0.88. And that's going to come out to 61.64. It didn't tell me where to round, so I'll just round to the hundredths place. So that's going to be 61.64. And that's degrees, because our answer is always going to be an angle. I'm going to skip the next one because it's the exact same one. I'll do a cosine one with you. Let's go ahead and do B together. So once again, to get alpha by itself, you're going to take cosine inverse of both sides. And I'm going to cross out cosine inverse and cross out that cosine. I'm left with just alpha equals cosine inverse of negative 0.82. Then I'll go back to my calculator. And we'll hit second cosine. And we'll do negative I already forgot what I was doing. Negative 0.82. And it's going to pop out 145.08. So that's going to be 145.08 degrees. And that is how to tackle those problems. So I think the hardest thing to keep track of is sine. That you cannot use 7 pi over 4. You have to use its negative angle. So once more, let's look at our unit circle. So if I'm dealing with sine, these are going to kind of disappear. And I'm going to be dealing with negative pi over 6, negative pi over 4, negative pi over 3, and negative pi over 2. That way we don't have to travel through that no-no land. All right, questions for me? All right, then.